Okay, so it says find the equation for the parabola that has this focus and this directrix. All right, so how are we going to do it? I want to come up with the equation. So has that focus and that directrix. That's kind of strange information they're giving us. You can make those decimals if it would help you. You don't have to. If you divide this on your calculator, you're going to get minus, what is it, 7.25. And this one is, I don't know. I'm going to use my calculator. Let me see. 17.25. You don't have to do that though, but it helps you. So anyway, I'm going to put these on an axis system. And see what we can see. That's a tricky one. I can feel it already. Right. And so. Okay, yeah, this is a tricky one. Okay. So, well, here, let me change my plan a little bit. So, try this again. Okay. We don't need very much height here. So what are the points? Well, this one is basically back 7.25 up 3. So I'm going to go find that. Back 1, 2, 3, 4, 5, 6, 7, and a little bit more. So here's back, so 7.25 up 3, 1, 2, 3. So it'd be about right there. You know, this is just for us. You don't have to be real exact. So that is what's at the focus point, and that's back 29/4 up 3, right? It's up at 3. So, okay, and then the directrix, it's interesting. They give us the directrix is over at 17. So that's way over 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.25, and up 3, right there. That's the, directrix line, huh? So I'm going to go dot, 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 dot. So there's the directrix line. That's x equals 69/4, which is just past 17. Okay, so there's our picture. Weird, huh? We got some weird information. What they're giving us is the directrix line way over there to the right, and then the focus point. And from just those two pieces of information, they want us to come up with the whole equation of this thing. How are we going to do it? Well, this is probably our hardest one so far. We're going to have to, step one, you're going to have to find the center, the vertex. So you're going to have to find the center, which is going to be the middle of the focus and the directrix. Now, how do I come up with that? Well, look at these pictures. See how the focus and the directrix, the center is always right in the middle of those two. Here we go again. Here's the focus and the directrix. Here's the middle of the parabola, right in the middle of the focus and the directrix. Now that's true even on the kind that are centered not there. Yeah, I gotta show you on a different picture though. If I can do that. No, it won't let me fiddle with it. And let me add it in. I can just put it in myself new. There it is. Yeah, so there it is. See how this vertex, right there, this vertex is right in the middle of the focus and the directrix line? It always is. Why? Because whenever you have your A number, from the center, you go from the center, up 5 to the focus, down 5 to directrix, or right, left, if it's right, left, whatever. You go the same distance. In other words, this is 5, this is 5. So yeah, the center will be right in the center. That's why it's called the center. Right in the center of those two always. Because from the center, from the vertex, you go the A distance up and down or right and left or whatever to get to the focal point and the directrix line. Yeah. So it's right in the middle always. Okay. So to find the center, I've just got to find the middle of the focal point and the directrix line. I got to find the middle of this and this. How do I find the middle of those though? Just kind of eyeball it the best you can. Well, the best way to find the middle by finding the average, right? Like if you got a 70 and an 80 on 2 exams and you wanted to know what's the middle, that's the average. The average is the middle. And you know how to do the average. You add and divide by 2. You know how to find the average of 2 things, right? You add them up and you divide by 2, don't you? That gets you the middle, doesn't it? So that's exactly what we have to do. We have to take the negative 29 fourths, which is that one, and add to it the 69 fourths. And when we're all done, we're going to divide by 2. You seeing that? That's how we find the middle of 2 things. We add them and divide by 2. Now, if you prefer to do it with decimals, you could. You could just use the decimals. I'm just going to finish it up the way it is. This will come out 40 fourths divided by 2. Now, how do you divide a fraction by 2? Well, actually, you know what? This is easy. 40 over 4 is just 10. Divided by 2 is a nice clean 5. So we could just do that. So it's 5, right? 34, right here at 5. So the center is right there. Now, it must be up 3 because everything else is up 3. I knew it was up 3, by the way, because everything else was lined up at up 3, right? This focus was up 3. This directrix, oh, wait a minute. I'm sorry. Only the focus is up 3, but that's good enough, right? All I need to know, the focus and the center have to be lined up, and this is over 5. So this is the vertex or the center, and it is over 5 up 3. See how I came up with that? I just averaged the focus point and the directrix line. I added them and divided by 2. Again, you could do it with decimals if you prefer, or with fractions. It doesn't matter. Good there? Okay, so over 5 up 3. So now we've got the center. Now, which way do these branches open? Well, remember the, see how the focus point is always inside the branch? If you look at any of these graphs, see, look at all 4 of these. I'm going to erase my previous scribbles. So the focus point is always inside the branches. Wherever the branches go, the focus point is inside of them, huh? So we go, oh, okay, focus point's inside the branches. So we come on back here and we go, oh, so then which way? It's got to go like this, doesn't it? Because the focus point has got to be inside the branches. And this is the center right here. And the directrix line is behind it. So that it's all making some good sense. Let me draw it. It's got to go like this and like that, right? With the focus point inside the branches and the directrix line behind the branches. So ours goes left, doesn't it? Our parabola branches go left. That's the most important thing to determine about a parabola, is whether the branches open up, down, right, or left. So now we know where the center is, and we know which way the branches are opening up, because the focus point is always inside the branches. Directrix line is always behind the branches. Okay, so now that I know it goes to the left, I can go get the general form of the equation. Let's go do that. So here's like all 4 directions from the notes. So we want one that goes left. Here's one that goes left. What's the general form of that equation? Y squared is minus 4ax when it goes left. So that's the general form of the equation. I'm going to grab that. Y squared equals minus 4ax. Let's go to it. So the equation, so we did step 1 here. Yeah, probably need to add a new page, do step 2. Okay, so come on down here and I'll do step 2. Step 2 is branches open left, So the equation, general form of the equation is y squared is minus 4ax, right? Because remember, the direction of the branches tells you the first power letter. Branches are going left. What's left? The negative x-axis is left. So negative 4ax is the right side first power letter. That always tells you the direction of the branches. So yeah, y squared is minus 4ax. But now the center is not 0, 0. So we gotta change it for the center. The center is what? What's the vertex? 5, 3. So that's x and y. Remember what you do now. You take the equation and you write y minus 3 squared is minus 4ax minus 5. See what happened? I grabbed the 3 and I did opposite to be minus 3, and I grabbed the 5 and I did opposite to be minus 5, right? So again, that's from the notes. If you look right here in the notes, the center is the opposite of the numbers next to x and y. So if you have the number next to x and the number next to y in the equation, it's opposite on the graph. So we've had that all semester long, right? Whenever you have an equation versus a graph, the numbers as they are in the equation are opposite on the graph. Same thing's true here for the parabola. So opposite, opposite of the y and the x. Okay, so now we're almost there. All we got left is to find a. Now just find a. We're almost there. We just need to find a. What's a going to be? A is the distance from the center to the focus point, or backwards to the directrix line. Either one, they're going to be the same because that center is the very center of those two. So you can jump either way. It's going to be the same. Going to be the same. Doesn't mean it's easy, but it's going to be the same. So in other words, let me bring in a new color here. So from here to there, that's A. A is the distance from the center to the focus or backwards to the directrix line, either one. Where am I getting that? Again, from the notes. Right here. A equals 5, which is the number next to 4 in the equation, right? When you write the actual equation. Anyway, it's from the center to the focus, up 5, or backwards to the directrix, down 5. See that? It's A, up or down, right or left, whatever, from the center to the focus or backwards to the directrix. So A equals 5 is from the center to the focus, up 5, directrix, down 5. So it's from the center to the focus or backwards to the directrix. That is A. Okay, so what's A? It's that distance from the center to the, well, how do you find that distance? A equals distance from center to focus. What's the center? 5, 3. What's the focus? Negative 29/4, 3. So those are both up 3, right? The 3 is not an issue. They're both up 3. We just need to know how far the jump is. Well, how do you find the distance between two x values? You subtract them. You subtract them. So the distance equals this x value minus that x value is 5 minus 29/4. Careful, double negative there. Subtract the x's to find the distance. Does that make sense? Let me make sure that's clear. I don't want that just to be something Mr. Heron says. But if I wanted to know how far from whatever this is, 6, 7, 8, from 9 to whatever this is, 10, 11, 12, 13, to 14, I would subtract them, right? And I take the one on the right first because that's the bigger one, right? 14 minus 9 is 5. That's the jump from 9 to 14, right? You just subtract. If you have two x spots and you want to know the jump between them, you subtract them. Well, that's exactly what I do here. I take the 5 and take away the minus 29/4. 5 minus 29/4. Let me erase all that. See, it's kind of cluttery. Right, so I'm going to go 5, and this is, so 5 and minus 29.4. Those are the two positions. Subtract those, and that's what I'm doing here. 5 minus negative, it's a negative 29.4. And you know what that's going to do? That's going to make it 5 plus 24. How do you add those? Oh, well, you can make it a decimal if you want. Just get a decimal answer. I'm going to put this over 1. I'm going to stay with fractions. I don't know if they want fractions. Multiply top and bottom by 4. So we get what? 20 over 4 plus 29 over 4, which is 49 over 4. That's the distance between them, 49 over 4. So that is A, is the distance from center to focus. That's A. A is 49/4. So with all said and now done, let me wrap up the equation. So it's y minus 3 squared is minus 4a x minus 5, and then I'm going to plug in that 49/4. This one's been a lot of work. Y minus 3 squared is minus 4 times a b 49/4. Multiply those together. This is over 1. These cross cancel, right? When you multiply it together to simplify the formula. Y minus 3 squared is the minus sign is still there though. Minus 49. X minus, with that 5 got a little sloppy. There it is. Again, probably would have been easier just to do decimals all the way through that problem instead of fractions, but it's fine either way. There's the equation for the parabola they are describing. That was a tough one. Let me recap what just happened there. A couple of tricky steps there. Let me recap. So what did we do? We put down the focus. I changed these to decimals to kind of identify and put down the focus point, back 7.25 up 3, and the directrix line, which was over 17.25. Then I had to find the center, which is right in the middle of the focus and the directrix. So find the middle of two things, you average them. You add them and divide by 2. That's the middle of two things, the average. Add and divide by 2. So I added them, probably easier with decimals. Just use your calculator to do decimals. Get 5. So that means over 5, and we know it's up 3 because they got to be the same height as the focus point. They got to be lined up. So over 5 up 3 must be the center. And then we knew the branches went left because the focus is always inside the branches. So for one that goes left, branches go left. So the equation is of the form y squared is minus 4ax, negative x direction to the left. That makes sense, okay? So then, but then the center was 5,3, so then you got to do opposite and opposite. So we get y minus 3 squared is minus 4ax minus 5. And then we just had to find a. What's a? A is always the distance from the center to the focus. You see that in all the parabola diagrams, distance from center to focus. So if I go from the center to the focus, I had to find that distance. How far from 5 to negative 29/4? So again, it'd be easier if you just change this to the decimal version, which was negative 7.25. Anyway, you just subtract those numbers. That's how you find out how far apart two spots are. You subtract them. Take the bigger one on the right, and subtract the one on the left. So I did that right here. I did 5 minus a minus 29/4, which 2 minuses become plus. I did a common number. It would be easier for you to just do decimals on your calculator. And I got 49/4. You would get whatever, 12.25. That's fine. Plug that in for A right here. That's A, right? That's what A is. A is the distance from center to focus. I subtracted center minus focus and got A, the distance. Plug that in for A, work it out, force cross cancel. There's our equation, meaning a statement with X and Y only, no other letters. There's the equation of that parabola. There we go.